Hello guys, in this video I'm gonna explain you a very complicated, you can say it's complicated game theory exercise. And this exercise is about finitely repeated games and infinitely repeated games. So let's look at it. Now we consider the following game in strategic form. And we can see in this game there are two players. Player 1 has three options, three actions, and player 2 also with three actions. And first, we need to assume the game is repeated twice. Does there exist an SPNE in pure strategies such that EE prevails in t equals to 1? Now we need to find a strategy given that this game is repeated twice. That makes EE prevails in just period 1. If you still remember what you have learned in the course, you know that for a strategy to prevail, for a cooperative strategy to prevail, there needs to be some kind of punishment. And that means for one player, for the players in this game, let's say for player 1 and player 2 in this game, if one of them refuses to cooperate in the first period, then the other player must have a means or a strategy to punish the player that defected in period 1, right? Because if there is no punishment, neither of the players have the motive to cooperate in the first period. And what can be the credible punishment? It must be some kind of equilibrium strategy in this game, right? Okay, let me just repeat it. For a punishment to be credible, the punishment strategy must be what? It must be a Nash equilibrium in the game. And also, if both players cooperate in the first period, there must be some kind of cooperative strategies, or we can say rewarding strategies for the players. And this reward will motivate the players to cooperate in the first period, right? And for the reward strategy to be credible, it also must be a Nash equilibrium of the game. So we see this is the stage game. What are the Nash equilibria? Are there any Nash equilibria in this game? We can look at it. Yes, there are. The first is CC, right? It gives the players a payoff of 3. And also, there is NN. It gives both players a payoff of 2. So, which can be the cooperative strategy and which can be the punishment strategy? This can be used to reward cooperation in period 1 for period 2, right? Oh, let me just put it another way. CC can be used in period 2 to reward the players who cooperate in period 1, right? And 2-2 can be used to punish the players who refuse to cooperate in period 1, right? Okay, so now the question is, will the punishment or the reward be effective? Okay, for the punishment to be effective, we must guarantee that if one of the player deviates, then deviates in the first period and gets the punishment in the second period, the sum of their payoff is lower than what? Is lower than he cooperates in period 1 and gets a reward in period 2, right? Did I put it clearly? Or let me just write it another way. for the punishment to be credible, we need to, or for EE to prevail, we need to guarantee that for player I playing EE in period 1, so this is they cooperated, right? And it will get a reward in period 2, which is, let's just remark it with the reward. The utility is larger than what? It is larger than he deviates. If he deviates, he gets a larger payoff in period 1, but the payoff of its punishment in period 2. Right? Only in this case, the cooperative strategy, which is EE, will prevail. Okay? So this is the general idea. Now let's see. We see this is a kind of symmetric game, right? Because both players get the same, have the same action profiles, and in each action profile they get the same payoff. So this is symmetric. For player 1 and player 2, they are basically the same, right? So let's say if both players, let's just say player 1, okay, because it's the same for player 2. As I said, it's a symmetric game. So if player 1 will not deviate, player 2 will neither deviate. Player 1 is the same as for period 2. Okay, now let's just say player 1. If he chooses to cooperate in the first period, it gets a payoff of 6, right? For the utility for player 1 of cooperating playing E, it is 6. And the utility of and we know they cooperate in the first period. That means they will play what? They will play CC in the second period. The utility for playing CC is what? Is 3. So the total payoff is 9, right? And let's see, will player 1 deviate? Given that player E will play, given that player 2 will play E, player 1 can get 3 types of payoff. 1 is 6, 0, and 8. So if player 1 deviates, to which strategy will player 1 deviate to? It will deviate to 8, right? Because this gives him a larger payoff. So if player 1 plays NE, you will get a payoff of 8. And as player 1 deviates in the first period, player 2 will play what? It will also play N to punish the player 1. So in period 2, both of the players will play a punishment strategy, and the payoff, the strategy is NN, and the payoff is what? The payoff is 2. So the sum of it is 10, right? And in this case, we can see even if player 1 deviates in period 1, this is the payoff is 10, is still larger than what? Is still larger than the payoff he gets by cooperating or coordinating in period 1 with EE. So, can EE prevail in period 1? Obviously cannot, because the payoff is smaller. The punishment is not punishing enough. It still gets him a larger payoff by deviation. Okay? I hope I explained it here. Now let's move on. And we assume the game is repeated 3 periods. Does there exist any SPNE in pure strategies, such as EE prevails in period 1? Okay, it's the same, right? So if it is repeated for 3 periods, it is repeated for 3 periods. The idea is the first case, not deviation, or we say no deviation. Okay. That means in period 1, both of them choose EE, and in the subsequent 2 periods, they will choose CC, the rewarding strategy, right? This is the first case. And the second case, with deviation. There is deviation. So, as I said, if there's no deviation, the components of the payoff is EE. They will play EE in the first period, and they will get what? They will play CC in the first period, and also what? They will play CC in the third period. And if there is deviation, for pair, just like pair, if I equals to 1, or we say if it's player 1 will just play NE, right? Because we found that it will give him a better payoff than playing EE. And then they will play AN in the subsequent periods. And in this case, EE equals to, let me see, 6, right? This is 6 plus 3 plus 3, this is 12. And this is 8. 8 plus 2 plus 2 equals to 12. So we can see when there is no deviation, player 1 gets 12. When there is deviation, player 1 also gets 12. And the utility is the same. So, does he have any motive to deviate? No, he doesn't, right? Because the payoff is the same. For him to deviate, we must guarantee that the deviation is larger than the payoff by choosing not to deviate, right? Okay, so what is the strategy? The strategy is for both players. Let's denote strategy with S. The strategy for player I, given the action profile in period 1, we denote with A1, subscript A1. Okay. If AI equals to what? Equals to EE. That means, if A1, subscript A1 equals to EE, that means if the action profile of players is EE, or both of the players choose to cooperate, choose E in the first period, then in the subsequent all periods, their action will always be what? Will always be C, right? To reward the cooperation in the first period. And if AI equals to what? If player 1 deviates, NE, or player 2 deviates, EN, or both of them deviates, AN, then the strategies for the players, for both of the players in the subsequent games will become what? They will choose N, right, to punish the other player. So this is the strategies of both players. Okay. I forgot to denote T. Okay, this is the strategy for player I in period T, and this is the content. I wrote it another way, but we means basically the same. Okay. And finally, assume the game is infinitely repeated. Okay. At this stage, we always assume this game is finitely repeated, right? Because it ends in 2 periods or 3 periods. It's a finite game. But now we assume this game is infinitely repeated for what values of the discount factor is the pair of strategies. This is the strategy. For this pair of strategies, for all T and SPNE. Okay. Now we first need to figure out what is the strategy. It basically says that the strategy for player I in period 2, given the action profiles of all past of the strategies in all past histories. Okay, we are looking back. When you are deciding your strategy in period 2, you look at the strategies, all past strategies, okay, all the history. And the strategy is that if some player choose C or N in the past, then you will choose N. And that means, remember, we will play EE, right? And if any of them ever choose C or N, that means if any of them ever deviated from E, then you will choose what? You will choose N. You will always punish the player. But if none of them ever deviated from E, they will play what? They will play E forever. So let me put it another way. The strategy is basically saying that this game is repeated infinitely. And if none of them ever deviated from EE, they will play EE forever. And if any of them ever deviated from playing E, they will what? They will always play NN in the subsequent games. So we need to calculate the discount factor that makes this strategy possible, right? What can be the discount factor? Let's see. There are still two cases. The first is that there is no deviation. And the second, with deviation. And if it is no deviation, as I said, they will always play EE, right? So the payoff like denote with U. The sum of the payoff is what? It is in the first period they play EE, and in the second period they also play EE, right? In the second period for player I, they also play EE. But what? But there is a kind of discount factor, right? Remember the discount factor. Sorry. And in the third period, the same. They will play EE, but discount factor is epsilon squared. And plus in the n period, EE and the discount factor n times sigma. But with deviation, what is the utility? I use U prime. That will be UI. We know in the first period, if they deviate, which gives them a better payoff. It's 8, right? For player Y, it's 8. For player 2, it's also 8. As I said, it's a symmetric game. So this will be in the first period, they will play NE. And in the second period, what will they get? What will they play? They will play NN, right? This punishment strategy times sigma. And in the third period, the same. NN times sigma squared and times plus, sorry, UIN, they play UIT, this is, let's use it to denote the times of the period. And this is also NN times sigma n. Right? Okay. What is the sum of it? And this will be 6 plus 6 sigma plus 6 sigma square plus 6 sigma n times, right? And this will be 6 times 1 plus sigma square n times. And this is we need to calculate the sum of geometric progression, right? This is a geometric progression. And this is 6 times 1 minus sigma, and 1 times 1 sigma n. Yes, right. And we see as sigma is a number smaller, it should be smaller because this is a discount rate, smaller than 1. N times sigma is basically what? It's basically 0, right? And so this is 0. So the sum of it is what? 1 minus sigma divided by 6. 6 divided by 1 minus sigma, okay? And this is the same. This gives them a payoff of 8. And this gives them a payoff of what? Of 2, right? So this is 2 sigma plus 2 sigma squared plus 2 sigma n times. And this is 8 plus 2 sigma, 1 plus sigma squared plus 8 minus 1 times sigma. And the sum of it, and this is 8 plus 2 sigma times 1 minus sigma, and and this is 1 times 1 minus sigma n minus 1, right? And also, as sigma is smaller than 1, this equals to 0, and the sum of it is plus sigma, this is 8 plus 1 minus sigma, 2 sigma, right? And to guarantee that there is no deviation, we need to make sure that this number is larger than this, right? So this is 6 over 1 minus sigma, larger or equal than 2 sigma, 1 minus sigma. And we times 1 minus sigma on both sides. And we know it will not change the direction, right? Because 1 minus sigma is still larger than 0. So this is 6 larger or equal to 8 times 1 minus sigma plus 2 sigma. And this is 6 larger or equal to 8 minus 8 sigma plus 2 sigma. 2 sigma. And this is minus 6 sigma. We move to this side, to the left side. This is 6 sigma larger or equal than, we move to 6 to the right side. This is 2. So sigma is larger or equal to 1/3. 1/3, okay? So this is the answer. As long as the discount rate is larger or equal than 1/3 or 1/3, there will be no deviation. And that means if the players are enough patient and their patience is, we say the discount rate is larger than this, the game will infinitely repeats, or we say EE will prevail in all the periods. Okay. But if they are not patient, they will deviate in the period let's say some period, and they will play the punishment strategy AM. But as long as it is the discount rate is larger than this, they will not deviate. Okay, they will play EE.